Okay, so we didn't have time to go into super incredible detail on recursive algorithms. So I definitely wanted to make sure that we went the extra mile and covered it in complete detail in a video for you. First, let's review the basics of recursive algorithms. The easiest way to do this is to start with a simple for loop and convert it into a recursive algorithm. That way you can recognize the difference and what goes where. So let's just start with this simple one where we're taking a word, and I'll give you a sample one there, and we're going to loop this length, or the length of whatever the input string is, and we're going to iterate down by 1 until I is for as long as I is greater than or equal to 0, and we're going to exit when I is less than 0. So my terminating condition or my escape condition would be the opposite of this, which would be I is less than 0. But it's going to continue running as long as I is greater than or equal to 0. And each time the loop runs, we're going to be printing out one letter from the string word determined by where I is in the iteration process. So we're starting with the highest index in word, which is this last letter here. We're going to print that first, and then we're going to, so it goes from I to, the range goes from I to I plus 1. Remember that the top of this range is exclusive, so if, let's say our index I is 0, it would go from 0 to 0 plus 1, which is 1. So our range is from 0 to 1, which is exclusive, meaning it's going to exclude the 1. So our range, the range that's actually going to get printed here is actually from 0 to 0. Same thing if I go all the way up to 7 or 8, I equals 8, I plus 1 equals 9. So a range from 8 to 9 is actually going to print whatever the character is from 8 to 8. So this is the algorithm for printing a single character. So what we're basically saying is we're starting at the last character in the word, and we're going to print a single character each time, going down by 1 until we get to the last character, which is at position 0. So we're going to start at here at the top index. We're going to print the R, print the E, print the T, and the S, U, B until we get to the B, and then the loop will exit. So essentially, this is the algorithm for printing the reverse of any input string, or the mirror opposite, right? So now let's convert this. Let's just double check and make sure that it works, and it does. You can see that that is the reverse or the exact mirror opposite of that. And then let's convert this to a recursive algorithm. So we'll start by making a new recursive method to create our algorithm. So we'll go public static, and then instead of void this time we're going to use string, because 90% of the time your recursive algorithms are going to have a return value. We're going to actually return something, and then we're going to call this reverse, and we are going to give this parameters, but I'm going to give you some context for those, so we're not going to do that just yet. This is going to be our recursive loop. So now our job here is going to be to learn what goes where in a recursive algorithm from the context of our loop. Where does our iteration go? Where do we calculate that iteration inside of a recursive loop? Where does the original value, the starting point, actually, where do we put that in a recursive algorithm? And where does our escape condition go? So our first key is in starting the loop. And in the case of a recursive algorithm, we start our loop by calling the method. We actually have to start the method running in order to get the loop started. So I'm going to call the method reverse. And if you recall, we were saying that reverse is going to take some parameters. We're going to start to deal with those now, because we have this starting point, which is word.length. That is something that we don't want to put down here. So if I set I inside of the method, what would happen if I did this is whenever I recursively call reverse, I would get sent back to the length of the word each time the method runs, and that would completely screw up our algorithm, because no matter what we do here with the iteration, there won't be an iteration because we're going to continually be resetting the value of I. So we can't put our initial value there. We can't put our start value there. And what I usually do is I put our start value somewhere else, right? And I put it into parameters, and that's actually the correct place to do it. So what we're going to do is we're going to say int I here. And the way we're going to set that I value equal to something is by passing it through into parameters. In this case, I'm going to pass in word.length and then -1. And we actually don't have that there. We use commas. And for our second parameter, we need to actually pass in the word, because at a certain point, we're going to need to start adding sections of the word to our output. So we're going to actually need access to the word. So that's going to be our second parameter. I'm going to put in word, and I'm going to create a parameter for it here, and I'm going to call it string s, or let's go string w. So now we have our starting index and the word that we need to operate on. Now it's time to create our escape condition, or our terminating condition. So first we need to lay down the opposite, the condition that's going to keep the loop running, and that will almost always in a recursive algorithm, that's going to show up as an if statement. So if, and then it'll just be the same thing that we had here. So we'll go if I is greater than or equal to 0, we're going to do something, and then otherwise we're going to exit the loop. And I'll show you what that looks like later. I want to focus on this for right now, because this is what's actually going to do our work for us. So in case you have not figured it out right by now, we don't actually need to print anything from here, but I'm going to do it anyway. So I'm going to just go ahead and throw a system out print here, and then I'm going to put a recursive call to reverse here. And in this recursive call, I'm going to put the word, right? So my word w, and before that, what's going to iterate down as the value of I. And what's cool here is that I can take this I minus minus, and I can subtract 1 from I here, so that when I call this and when this loop runs again, I is going to be 1 less than it was before. And we're always going to do this check. As long as I is greater than or equal to 0, we're going to print this out. And we're always putting back the original word w in there. And if the above is not true, under our else condition, our escape condition, let's just print an empty string so that nothing gets added if that's the case. Now the only thing left I really need to change is I got to change that word to a w, because our variable that we have access to is w right now, and it holds that value. And actually, you'll probably have figured out by now that we're not returning anything here, so we don't actually have to have a return because we're printing from here. There's a different way to do this, but this is probably the easiest for the algorithm that we have. So if I just run this, you can see I print the reverse, and it all works the way that it's supposed to.